Alright, let's talk about the basics of solving triangles, because it's a lot more than just finding a side or an angle. There's a whole process and procedure you should go in, you should follow to do these triangles, and if you get them down before it becomes a story problem, it will be so much easier. So if you know you have a right triangle, then the first thing you want to do is draw a right triangle. When we get to the section on non-right triangles, then you would obviously draw a non-right triangle. It is only a right triangle if the information says it's a right triangle, or if you know that one of the angles is 90 degrees. So we're going to label one of the angles alpha, the other one beta. Okay. So let's just make a little list here. So step one was draw the triangle. Okay. Step two is correctly label. Alright, so the hypotenuse is always labeled C, and the side opposite alpha is always labeled lowercase a. The side opposite beta is always labeled lowercase b. So in order to solve a triangle, you need three measurements. So you can have two sides and an angle, two angles and a side. You can have any combination, except you need, let's put a comma here, you need at least one side measurement. Alright, another thing to talk about is solving. When it says solve, what does that mean? That means find all angle measures and side measures. That's what that means. Another thing that we're going to do is we're going to save all calculations, like when we pick up our calculator, calculations until the end. I will demonstrate this. This is really even more important when we get to non-right triangles. If you start picking up the calculator at the very first calculation and then you make rounding decisions, it will just extremely affect your final answer. So we're going to save all of our calculations to the end. So here's some other common rounding. Unless otherwise specified, we are going to round our sides to hundredths, unless otherwise specified, and we're going to round angles to the 10th place, unless otherwise specified. And then the next thing we're going to do is we're always going to start, well, we started with the triangle, so next we're going to start with a chart. And I will show you in this example what I mean by a chart. Okay. So there's the basics of solving, and let's go ahead now and do an example and see how all of this works. All right, so we have, in this example, beta is 30 degrees, and we know it's a right triangle. That's a little symbol for triangle. And we know C is 10, and we want to solve the triangle. So the first thing we're going to do is we're going to draw a right triangle. Okay, there's my right triangle. Beta is 30, so I'm just going to say that that's 30. So if that's beta, then that's side B. C is 10. C is always the hypotenuse, so there's the 10. I do not know the other angle. I'll call that alpha. I do not know this side. I will call that A. And then you're going to make a chart. On the handout I gave you, I provide a chart. On all the homework papers, you're going to make your own chart. And we're going to have A, B, and C equals. And on this side, we're going to have alpha, beta, We're going to call this gamma, even though we know it's 90 degrees. When we get into non-right triangles, we will call that side gamma. So you could call it gamma right now, and it's always, for right triangles, it's always 90 degrees. So notice how the A of the side is kind of lined up in the chart with the alpha, the B is lined up with the beta, and the C is lined up with the gamma. And then notice in the figure how the side is opposite the angle. This is the pattern I always want you to follow when you solve these. Next thing we want to do is fill in stuff that we know. So we know that beta is 30 degrees, and we know that C is 10. Alright, so that's what we do to start, and now we're going to solve the triangle. Okay. So let's first start by solving for alpha. So we know that the measure of all triangles, all angles in a triangle equal 180. So that means that if I added up alpha and beta and gamma, it would all equal 180 degrees. So alpha plus 30 degrees plus 90 degrees equals 180 degrees. Now some of you might say, hey, this is a right triangle. This is always 90 degrees, so why can't I just say alpha plus beta equals 90? Yep, absolutely. No problem with that. One reason to do it in this feature, or this manner, is because this gets us ready for triangles that are not right triangles. But there is nothing wrong with doing this. Nothing at all. In fact, if you do it this way, this maybe kind of helps you with the co-function identity. So let's see, beta was 30 degrees, so if we subtract 30 from 90, we get 60. So let's go ahead and fill in that 60 degrees. Alright, so I need a little bit of room here. Let me erase all this stuff. Now I know my angles, and so now I can figure out the other two sides. Alright, so let's start with, it actually doesn't matter which one you start with. Let's start with cosine. So I know that the cosine is equal, cosine of beta, let's start with that one, cosine of beta is equal to the adjacent side over the hypotenuse. So the cosine of beta is 30 degrees, so that's going to be the cosine of 30 degrees. And the adjacent side to 30 degrees, I don't know that, that's my A. The hypotenuse is 10, so I can fill that in. Alright, so let's solve that one and move up here. And as I do that, I'm going to multiply both sides by 10. So I'm going to have 10 times the cosine of 30 degrees equals A. Then I have 10 times the cosine of 30 degrees is square root of 3 over 2 equals A. And so A is going to be 5 times the square root of 3. So let's write that in. 5 times the square root of 3. Alright, you'll notice I'm doing this in exact values. There's nothing wrong with doing it in exact values. Then you don't have to worry about rounding it off. Alright, so we've got that. Now let's find B. And let me do some erasing here. Alright, so it's a right triangle, and some of you might be thinking, hey, I don't need to use this trig to find B. I can just do a squared plus b squared equals c squared, the old Pythagorean theorem. Yep, but let's do the trig to get practice, because you're not going to be able to do Pythagorean theorem when we get to non-right triangles. So it's a good practice to get into using your trig formulas. So now I know that the sine of beta, and by the way, I'm using beta in all these. I could easily have used alpha. It doesn't make any difference. The sine of beta, the formula is opposite over hypotenuse. So I have the sine of beta. Beta is 30 degrees. And the opposite is unknown. That's our B. And the hypotenuse is 10. Let's multiply both sides by 10 because we're solving for b. So I have 10 times the sine of 30 degrees equals b, and let's transfer this work up here. So I have 10 times the sine of 30 degrees, well that's 1/2, that equals b, so b equals 5. Alright, so there's an example of using your trig formulas to solve a right triangle. It's solved when you've got all three sides and all three angles.